Welcome to video number 315. In this video I am going to estimate logistic regression model, and I'll interpret the results of the logistic and logit models, and finally I'll also forecast some values for the logistic regression models, their laggards and some probabilities. So let me start with some introduction. If you remember, in my previous video, I raised this question: why can't we use linear regression model when our outcome variable is dichotomous or binary categorical? The answer for this is that in case of binary dependent variable, our forecast could be outside the range of the probabilities from 0 to 1 range. So can we fix that? Yes. In order to fix that, to restrict the probabilities between 0 and 1, we may use logistic regression, and which is given by the following function. On the right hand side, there is natural log of p over 1 minus p, which is also known as logit or laggards, and rest of the equation on the right hand side looks like a linear combination. We may write this equation as follows. Instead of log p over 1 minus p, we can write y star is equal to beta naught plus beta 1 x1 plus beta 2 x2. This equation looks very familiar to a linear function. Before I explain it further, let me explain the probit and logit models are estimated by using the maximum likelihood method. In order to interpret the coefficients, we can say that n increase in any independent variable increases or decreases the likelihood that y is equal to 1. That is, it makes the outcome more or less likely. In other words, n increase in x variable makes the outcome of 1 more or less likely. We interpret the sign of the coefficient but not the magnitude, because the coefficients for the various models are different. The magnitude cannot be interpreted using the coefficient because different models have different scales of coefficients. If you look at the following comparison, it means that coefficients differ among different models because of functional form of the f function. And some researchers have reported that the coefficient of the logit is approximately 4 times of the coefficient of the OLS model. Similarly, the coefficient of the probit model is almost 2.5 times of the coefficient of the OLS, and the coefficient of the logit model is approximately 1.6 times of the probit coefficient. So we should not compare the magnitude of the coefficients among different models. There is difference between logit model and logistic model. If we run the regression using logit and then the dependent variable, the binary dependent variable, and independent variable log, then we have the coefficients which are here. I'll do that in stata. But if we use logistic command instead of logit, then here we don't have the coefficients but we have odd ratios. Similarly, if we use multiple regression and with the command logit, then we have coefficients for age, gender, and the constant. Similarly, we can also have logistic command for the same variables, and you see here these are the odd ratios for the same variable: age, gender, and the constant. Here is the estimated model with the logit command, and this is the coefficient. Now, sign of coefficient still represents positive or negative influence on the outcome variable, which means that age is positively related to the outcome variable, that is joining the club. And we can use the standard error of the coefficient to find out the estimate of the confidence interval using this formula, where 0.0716442 is the coefficient from here, and then we will sum it or subtract 2 times the standard error of this from this coefficient. So our lower limit is 0.0322 and upper limit is 0.4660. Now what has changed? We can no longer interpret the magnitude of the coefficients as we did in the case of a linear model. So what is the meaning of 0.0045 in our model? And this coefficient is here. So what does it mean? Let me explain it. What is the meaning of 0.0045 in our model? In this, natural log of p over 1 minus p is equal to minus 2.9013 plus 0.716442 age. Age is the independent variable. When we think in terms of a linear model, we would have interpreted this for every unit increase in age, log odds or the logit increases 0.0716 by units. But what exactly is a natural log of p over 1 minus p? Let us suppose we replace natural log of p over 1 minus p by y star, then we can, and we don't know what does 0.0716 units increase in that particular y star or log odds mean. So it means natural log of p over 1 minus p increases 0.0716 by units, and if we have y star which is equal to beta naught plus beta 1 age, then we can estimate or we can predict the probability by this transformation, that p is equal to e raised to the power whole this linear combination divided by e raised to the power beta naught plus beta 1 age plus 1, and finally we can write like this. Now we can simply put p as exponential e raised to the power y star is this, which is also equal to beta naught plus beta 1 age, and again divided by exponential of y star plus 1, and that is equal to e raised to the power y star divided by e raised to the power y star plus 1. So it looks very complex, but it is very simple if we go step by step. So I am going to have an example in Excel to convert those y's into probabilities in 2 steps. So let me open my Excel file, and here is my XN file. This is, remember, this is join is equal to 1 if a person joins a club, and this is equal to 0 if he or she doesn't join the club, and this is the estimated coefficient of the constant, and this is the estimated coefficient of the age. Now we are using simple logistic regression. This is variable, this is constant, this is age. These are the same like here. Now we are going to estimate the y star or the log odds for a 35 years old individual. So we put 1 for the constant and 35 for the age. So here, if you look at this, I have given this formula sum product, this multiplied by this plus this multiplied by this, so we get this. And if you want to predict probability, then we will have exponential e raised to the power this divided by e raised to the power this plus 1, and if we simplify, then we have this probability, that is the probability that a 35-year-old person will join a club is 0.40 or 40%. Similarly, the probability of 36 years old person is 0.42 and the change is 0.01. We can also predict probabilities and log odds for 15 years old. So this is the log odd for 15 years old, and this is the probability for a 15 years old person, and this is log odd for 16 years old person, and this is probability for a 16 years old, and this is change in the probability. And similarly, this is change in the probability when there is change in age from 39 to 40. So if you look at these probabilities, these are different. Here it is 0.017, here it is 0.008, these changes, and here this change is 0.017886. Since this change is not constant, that is why we call logistic regression as a non-linear regression function. And this is also again for a multiple regression function in which we have also used as dummy variable. It is equal to 1 if female and 0 for male. Now this is the log odd for 34 years female, and this is the probability of a 34-year female to join the club, and this is the log odd for 34-year male, and this is the probability of a 35-year male. So the probability has decreased. So this means that the male are less likely to join the club as compared to the female if they are of the 35 years of age. Similarly, these are the log odds for 36 years female and 36-year male, and this is the probability for 36 years age of male, and this is the probability for 36 years of female, and this is change in the probability. So this is how we can estimate probabilities from coefficients using. So these are two steps. First we estimate log odds or the logit, and then we estimate the probabilities. So now I go back to my presentation, and I can show this to you. Now again, this is the table that I just explained in the Excel. Now this is change in the probability when age increases from 35 to 36. This is change in the probability when the age increases from 15 to 16, and this is change in the probability when the age increases from 39 to 40. So all these changes in probabilities are different. This is the logistic model plot. This is its density function. This is for multiple linear regression function. This is almost the same as the simple linear regression, and here we increase one more variable, that is dummy variable for the gender, and we have this estimated equation that I have already interpreted in Excel, and this is the same table that I explained in Excel. Now this is the change in the probability from female to male of 35 years of age, and this is the change in the probability of 36 years from female to male, and both these are different. So that's why these are called non-linear model. Ladies and gentlemen, I would also like to show the same regression using Stata. So I have used this do function, do file. My data is here. Now join is a binary variable, 1 for yes, 0 for no. Gender f is equal to 1, m is equal to 0, and this is age in years. Now let me. So this is the logistic regression in which we have odd ratios, and this is the Logit function in which we have these coefficients, and these are the coefficients that we use in Excel to compute log odds and probabilities. Now this is the multiple regression for the logistic. These are log odds, and these are the Logit function. We have coefficient, and we can also use another command Logit